in-class portion of the final exam will be Tuesday, May 29th from 8 to 11. Okay, so let's start by reviewing some electrochemistry. This was supposed to be your quiz last week, and of course you didn't get the quiz last week. So why don't we do this first, just for practice? You can do this with the person sitting next to you, or in front of you, behind you. This will also be the start of your review for your final exam. And let's see, so we have 1, 2, 3, 4, 5 questions. So let's see. I'm guessing it should take you 45 seconds per question. Therefore, 45 times 5 is 225 seconds. So that should take you about a little less than 4 minutes. No, so don't worry about that. Don't write the questions down. Just write down your answers. Okay, so again, this is not a quiz to be turned in, this is just a practice. Okay, so you're not turning anything in. Unless you want to. Do you want this to be a quiz?
No. It could be extra credit.
Wait. Now, I actually think it's more important that you work on the actual assignments rather than expecting extra credit for everything.
Right.
Now remember that your textbook is a reference source which you can use to answer these questions. So for example, for question 1 is a car battery described in chapter 19 in the textbook. And if you take a look on page 681 and 682, that describes the lead storage battery. So that's section 19.6 in the 6th edition of the textbook.
What's the piezoelectric effect?
The piezoelectric effect is you have a substance such as quartz, and if you apply if you flex it, so for example, if you have, let's say this is some piece of quartz, if you flex it, it'll actually produce a voltage across that substance. Or if you apply a voltage across it, it'll actually flex. So that's how, and then if you apply a voltage, it actually flexes at a constant frequency. So that's why these piezoelectric devices are used in timepieces and watches. Okay, so car battery is a lead oxide cell. What's the electrolyte in the car battery? Yeah, sulfuric acid. What's the concentration of the sulfuric acid?
18 molar.
18 molar. Okay, when the battery is charging, okay, now note again that the car battery is rechargeable. So in one direction, that's discharging, you produce electricity. In the other direction, you have to supply energy to charge the battery back up. So in the charging direction, what is the reaction which occurs at the anode, and what reaction occurs at the cathode? Okay, so George, you're giving the general answer because at the anode, oxidation will occur. So what's the reaction? Okay, so you're saying lead plus sulfate. Okay, so in this case here, what's being oxidized? Okay, and then at the cathode, this is where reduction occurs. So what reaction occurs at the cathode?
Lead oxide.
Okay, so you have lead oxide.
400.
Plus sulfate.
Plus 2 electrons. Okay, now how do you know that this is the reaction which occurs in the charging direction, and this is the reaction which also occurs in the charging direction?
Because of the 2 electrons coming out of the oxidation, and then when it's reducing, it's gaining the 2 electrons.
And at the anode, the lead's more active.
So you're saying that lead is more active than lead oxide. Well, if that's the case, isn't this the discharge direction then?
Yeah.
So is this the reaction which occurs when a battery is charging or discharging? Yes, this is actually the reaction which occurs when a battery is discharging. Now, what happens in a car battery is, okay, so here's your lead electrode, here's your lead oxide electrode. We know that the electrolyte is sulfuric acid. Okay, so when the lead is being oxidized, a layer of lead sulfate forms on the surface of the lead. And then when the lead oxide is being reduced, lead sulfate is being formed on the surface of the lead oxide. So when the reaction occurs in the reverse direction, the lead sulfate turns into lead oxide, or the lead sulfate turns into lead. Okay, so for this these two reactions showed in the discharging direction. So if we want to show in the charging direction, what do we need to do? So getting back to our car battery, in theory, a rechargeable battery should be, you should be able to use it forever. But the reason you can't recharge a car battery forever is because the lead sulfate, which forms on either the lead oxide or lead electrodes, it falls off. And then if you don't have any lead sulfate on the surface of it, then you can't go in the reverse direction. Okay, let's go into part C. What is the minimum voltage that will charge a battery? Yeah, so we said that for one cell in a car battery, that produces 2 volts. So to charge a battery, we need to our applied voltage. Like George says, that's to be minus, what would you say, 2.01 volts. Okay, so that's the minimum required to charge one cell in a car battery. If we want to charge the entire battery, how much volts do we need? 12. Yeah, we need 12 volts. Because there's 6 cells in series in the car battery.
How should you get the negative 2.01?
One way to do that is if you look at these half reactions here, you can look up in table 19.1 the standard reduction potential for this one as well as for this one. Reverse the sign for the reduction, naked oxidation, add them up, that gives you your cell voltage. That would be for the discharging reaction. For the charging itself, change the sign.
Did you write that?
Right, what I'm getting.
What you just said? Like, it's explain.
You have your textbook with you? Turn to table 19.1.
So you just take the
And for this one, so what's the reduction potential for, actually let's do this one first, the cathode. What's the reduction potential for that one? Let's see, for this one, the cathode. So for the lead oxide, that's yeah, that's 1.7 volts. Okay, so U reduction is plus 1.70 volts. And then for this one, if we look at the reverse of this reaction, that gives us a reduction potential, but no, we want to look at the oxidation. Okay, so what's going to be the oxidation potential for this reaction? Okay, so this would be plus 0.31 volts. So for each cell, this is equal to E oxidation plus E reduction. So that's going to be plus 0.31 volts plus 1.70 volts, which is 2.01 volts. And note again, for a charging reaction, sorry, for a discharging reaction for a battery, E cell must be positive, and the reason it has to be positive based on thermodynamics is because of what equation? Yeah, delta G equals negative RT minus N times F times E. Okay, so if E is positive, delta G is negative, that tells us the reaction is spontaneous. Okay, so again, this is for the discharging reaction. This produces energy. So if we want to charge it back up, that's the minimum energy we need to supply to charge the battery back. Okay, so at this point, are you experts at batteries? How come you guys don't have so much confidence in yourself? Because you guys made several batteries in lab. You actually made them with your hands. Still, but see, when you were younger, like when you're 7 or 8, you think you're experts at everything. So how come all of a sudden you don't think you're experts after looking at batteries? With that, someone your lap phone is smacking in your face?
Question. There was batteries, AA batteries for wallets that I remember, and they had 2 little points that you could put your fingers on, and then you hold it and it would tell you how much to charge.
Yeah, no, I've seen that.
How did that work?
Well, I'm guessing that there is a, I mean, since our body has, water in it and salts,